Namaskaram everyone, welcome back to the 7th episode of our Master Unreal series, and in this episode we are going to implement a robust, full-fledged gameplay tag manager, and here's a quick demo of that. You can see in the left side I have my tags that can be read by anyone. It could be AI or animation blueprint or anything, and in the right side we have displayed the tag which user wants. So for example, if I'm holding the shift key, I want to run, but I cannot run because I'm not moving. But as soon as I press W, I can start running. So all these synchronization of keys, user inputs, and the behavior of the game logic is integrated in this tag manager. So let's just get started. Okay, so the first thing we need is the widget. So let's just quickly create one. In the content, you can create a new folder, call it widgets, and under this you can create a new widget and you can search here widget blueprint. Select on this one and give it WBP, that is widget blueprint underscore log UI. In this, we are going to add a canvas. Once you are done with this, search for text, bring it out here and position it right here. Then we can increase the font size a bit. Let's go to font and make it 36, and let's increase this one as well. Now duplicate it, move it here and change the anchors to the top right, and you will see the flower will come here. Now we are going to rename it user vars, that is user variables. We are going to log this, and here we are going to replace the text with user wants colon, that's it. And this text box is a variable, so its value can be dynamically updated by the event blueprint, and we will also make it variable, and let's give it a name tags. And in the text under the content you can name it to tags colon. Okay, this is the default that you will see. So if I save it, compile it, now if I go to my third person blueprints, character blueprint, this is what we did last time. So let's just break this node for a second and move our content a bit here, and now search for create widget. This will give you this constructor, and you can provide your class here, that is your blueprint that you created. Now after this we are going to store this into a variable, call it debug interface, and change its type to the one we created, so WBP log UI object reference. Now bring here by pressing alt, connect it, pass the value, and it gets saved now in the variable. Now from here we will call the add to viewport. Now once the widget is created, we want to add it to the viewport so that we can see. So we will provide the value, that is the debug interface that we have just stored, and now we can save it and compile it and play. You can see tags and user wants are visible. Now before we move further, if you haven't watched the previous episode, I highly recommend you do that, because we have already implemented the blueprint class of the gameplay tag manager. I request that you check that out first and then you come back to this part, because from here certain things are already implemented and we are going to enhance them. So let's get started. So now let's modify our logging mechanism. We are not going to use the print string anymore. Let's create a function for that. Get tag suffix. Now we will take tag as an input, search for gameplay tag type, and I'm going to return it. So before we return it, we want the last part of the tag, that's why the function is created. So get tag name, press enter. Now parse it into array. After this, you are going to provide the delimiter as dot, because the tags are separated by dot, like input dot state dot moving or state dot movement dot moving, like that. So we want the last part, and then we are going to enable the context sensitive and search for get. This will give us the reference of the values. I want the second index, and then I want to return it in the output. If I hit compile and go back to our event graph, and now if I connect our function here, and I'm going to remove this print string, and now I want to bring our function get tag suffix. This will give us the value. We have to pass it the tag, so it will be the array element. So let's create a variable that is going to store the value that we want to print on the interface. So we will call it debug value, and we are going to change its type to string. Okay, now we are going to put everything in this string, and we will finally pass it to our interface so that it can print. And to put everything into this string, we are going to search for append string, and this is going to give us this node. Now add one extra pin here. So first we want the existing value of this debug value, pass it, and then the second would be the tag value, and the third would be the line break. So press shift plus enter. This will break the line and give some spaces. Once this is done, it would be like first nothing, then the tag, then line break, and then some space. You will get it. And then we are going to set this value to our variable again, put it here, and now this variable value will be passed to our interface. So for that, we are going to go in the interface, switch to graph from here. Now create a custom event, call it display active tags. Now this event is going to take an input. So here you can add an input. So let's call it tags and write it string. Okay, now the type is string, and we can call the append node again, and here we are going to connect this to B, and in the A we will say tags colon. Now to print this value on the interface in the place of variable that we created, we are going to add a node called setText, and you will find under this, do make sure your context sensitive search is off, and here we are going to provide the variable object and get tags, pass it here, connect this to this, and return the value this to this. Okay, we are all set. And now let's go to our blueprint third person character. Here we are going to call that event. So search for display tags, active tags. Make sure the context sensitive search is off to get it fast. Now this is going to set, but we need the reference of that interface. So bring this debug interface variable here, pass it here, connect this output to the tags. Now if we compile and play, you can see we are getting our tags. Okay, but it is too long. We don't want this. So what we are going to do before we start printing, we are going to set its value to empty string so that it starts fresh every time. We can add more space here and compile again, play. Okay, now we are good. And now it's time to create our tag manager a little robust. So let's head into it. So this is what we created last time, these 5 functions and 1 gameplay tag variable. So we are going to add 2 new functions that are going to allow us to add and remove the tag without performing this validation layer. So this is for classes that are going to use this component, but internally the manager, this gameplay tag manager, should be able to add tags without any restrictions or validations. So for that we will create a function exclusive add. Okay, so this exclusive add is particularly for the manager, and now add the input tag, whatever the tag that you want to add, and we are going to copy the implementation from here just copy it, paste it here, and before proceeding we want to check if the tag is valid, because sometimes you might make mistakes in the game logic and you might end up adding something that is not valid. We don't want that, so we will just connect it. We also need to bring this here like this and connect like this, then save and compile. And now we are going to create another function, name it exclusive remove, that is going to allow us to remove a tag. Now this will possess one extra functionality which will be revealed in a second, that is tag, and just copy the stuff from here, remove tag, and paste it in the exclusive remove. Once you're done with this, now again we will check whether the tag is valid or not. So once you do that, we are going to have a branch node, connect this to this and this one to this one, and let's search for get tags to have some clean. This is one. Now we have done the basic removal. Now let's say sometimes you might not want to remove the tags directly. You know the parent, and then you want to remove any tag which has the same parent. So for that we are going to have another parameter, that is remove any match, and this should be boolean. So if it is true, that means we have to search the gameplay tag container and we have to remove all the tags that are appearing with this tag. Okay, so for this we are going to search break gameplay tag container, and this is going to take the gameplay tag as input. I'm going to duplicate and connect it, and then I'm going to run a for loop, and this is going to be executed when this is true. So let's make some space for the branch node here. Let's add another branch node and search for get remove any match, connect this to this. So if it is true, then in that case we want to connect this to this. So now the loop is connected. Now we will bring out a branch node. Now we are going to take this array element, search for matches tag, and this has to be plugged in tag 1 because tag 2 is the parent one and tag 1 is the full tag, So we are going to bring the tag here. So get the tag and connect this to this. Okay, and now this value would be plugged in this. So if it is the match, that means we have to remove. So let's just duplicate it instead of plugging it directly over there. And this, after removing, we also have to notify others. So do make sure that is happening, and then connect this to this. And this array element should be passed here as well. Okay, I hope it makes sense. Now once this is done, we are all set. But let's say if you do not have this condition true, it is just a direct removal, then we are going to plug this to this. So before we start, I want you to understand the situation real quick. Now please focus. We have crouching and standing under the stance, walking, running under the locomotion, and the falling and moving under the movement. So falling is completely a situation where you cannot do anything, okay? But if you are in moving stage, then there are a lot of things that you can do. You can crouch, you can stand up, you can go from standing to walking, or basically you can do standing and walking together like I explained in the last video. Now these bidirectional arrows, why I made is because I wanted to tell you that all these functionalities are flexible. That means you can switch from any state to any state. Now I understand that in the animation blueprint we are going to do all this thing, but when it comes to gameplay tag, we need to update all these things properly so that the tags can be read by other pawns, AI controllers and all that very easily, and that will help you to create more sophisticated, complex and challenging situations for the person who is about to play the game. So for this I'm going to consider the two primary use cases. Please understand this is not all the cases, but the code works in all the cases. I'm just considering two of them to demonstrate what we are trying to implement. So why these are of two different colors, you already know that from the previous video. But the idea is you can run and walk in the standing state. You can switch between run and walk, Okay, but if you want to switch to crutch state, then we want to disable the running, because that's the idea in our game. We do not want to allow running when you are in the crutch state. So if you switch from any of this to crutch, then you are going to disable running. You are not going to allow running. If you are in a walking state and you switch to crutching, you will keep walking but in a crutch state. But let's say you are running, then this running animation will be converted into the walking, and then the crutching state is going to be applied. Now this transition or this modification has to be done by the gameplay tag manager. That's the idea. We do not want the character blueprint to store all that logic, and also we do not want to replicate that logic in every blueprint character. Now let's consider another situation. Let's say you are now in the crutching state. Now in the crutching state, you can either stay in the idle position or you can do the walking, right? But now let's say if you want to run and you are in the crutch state, then as soon as you press shift to run, I want the state or the stance state change to standing from crutching. Okay, and if I am walking and then I start running, then also it should work, but we have to make sure that we stand up. Other situation, if you are crutching and you are in idle state and suddenly you start running, then also we want you to stand up. So this is the logic that we are going to handle in the gameplay tag manager implementation. So please take a pause, have a look at it, try to make the use cases and test cases in your mind before we dive into it. And if you are not able to do that, it's absolutely fine. Once you will start implementing stuff, you will get these questions and you can always come back to this point of time. I will make sure that is present in the chapters. Okay, so let's start. Okay, let's open the add tag validation now. This is what we did last time. We are going to make some modification here. So let's remove all this. Now we are going to check this tag with the help of the macros that we designed. So let's bring out the determine tag here, connect this to this, this to this. So if the tag is from the stand state, that means the player want to switch the stance, standing, crouching or proning. So for this we are going to return the node and we are going to say you are allowed to do that. And if the tag is from the movement, then also we want to allow. And now if it's the locomotion tag, then I want to bring the branch node here. Now why I brought this is because the locomotion is only possible when you are moving. Okay, so if you are not moving, you cannot perform the locomotion. So if you are holding the WASD keys or whatever movement keys you have assigned in the controller, then only this locomotion should be processed. So for that we are going to create a variable, call it a movement tag, change its type to gameplay tag and give it a category active tags by the user. Now we are going to bring this node here and we are going to search for matches tag. This tag is going to be present here and I want to check if you are moving or not, and I'm going to plug this here. So now if you are moving, then we say return. Now when it comes to is allowed or not, the answer is this: if you are moving, then the locomotion is allowed. If you are not, then it is not allowed. We will create a new variable, locomotion tag. Now this will hold the information what type of locomotion you wanted to perform, but you couldn't because moving tag was not present. Okay, you were not moving, so your locomotion was not allowed. So we have to store that, because let's say you are holding the shift key, that means you want to run, but your W key is not pressed and you are not able to move. So that's the reason the running locomotion has been declined. So we need to store that so that when you will press W, that would be detected as a movement tag. So as soon as the movement is allowed, we want to also allow your locomotion tag that you are still pressing. Okay, so for that we have to store this. So we are going to bring this here and we are going to connect this and we are going to search for get, and we are going to search for get tag. That is basically the tag that you are receiving from here, and we are going to put this here. So we are just holding this information till you get your movement active, and then we are going to return it. So I have beautified a bit. Let's hit compile and save. Okay, so the tag validation is done. Now this validation function should only be called in the add tag, because this is what the users or other blueprints will call. To make it a little good, we are going to add a return node here, so that you have the eye on this upper layer, that if this condition is false, that means the function will stop here. So having the return node gives a clear view where are the places where the function is ending. And now since we are already having these three parts in our exclusive add, what we can do is we can remove this and we can just call the exclusive add, because exclusive add is doing nothing but just adding the tag and notifying. We do not need to repeat that same logic here. Instead, we can call this function. We have to connect this to this. So once the tag is added, that was allowed by the validation layer, so we have to make the changes that we discussed, the side effects. Okay, so for that we have to create another function, call it update tags after adding. So now this is where the fun begins. Now first thing, we are going to know the tag. So this was the tag that was allowed and was added by the function. So we need to check that. So instead of bringing this determine tag again and checking which was the parent, what we can do is go to our add tag validation and we will create a enum from blueprints. So I will call it e underscore single tag categories. Okay, so the idea that we discussed in the previous episode, I'm going to recap it here, that there is a possibility that you allow one tag out of a category, and there is a possibility that you allow multiple tags from a single category or from different categories. So in this case, we are going to add 3 here. We are going to name one locomotion, another one is movement, and the third one is the stance. So these are these 3 single categories from which you can select only one tag. Other than this, there is a possibility you can select multiple, but we are not focusing on it right now. In the function, in the outputs, I'm going to say tag category. Now do not write category, otherwise it will group in some default category that Unreal has. So just name it tag category and change its type to e underscore single tag categories. Now if it's stance, then we are going to say, hey, it's a stance category. If it is movement, then we are going to say movement, then it is locomotion by default. Okay, save, compile. Now we go in the add tag. You will see after the validation you have the tag category. So now after the tag has been added and people are notified, we are going to process the further updates. For that we created this function, so let's bring it here. And now we are going to go in this function and we are going to ask in the input that what was the tag category. Okay, because this function is supposed to be called by the add tag, so it is going to tell us what was the category of the tag that was added. So I'm going to go here and I can plug this output here. Now we are good, and we also need the tag that was added. So for this we are going to bring it here. Okay, we are all set. Now let's save and compile again and go to this. Now we are receiving the tag category, so we can use switch node, switch on e underscore single tag categories, and you plug your tag category here. So now let's start from the easy part. Let's focus on this stance. So if the tag that was added by the stance, that means whatever your stance that was previously will be removed. See, let's say you are in a standing stance and then you change it to crutch. So we want to remove the standing tag from the container. We remove that first. So let's call the exclusive remove. So now we need the tag. So again we will create a variable that is going to store the stance tag. Now please understand, we are not going to create variables for all the tags, otherwise it will become useless. You can use variables instead of gameplay tags. The idea is to create variables for only single category tags. Okay, so I'm going to bring this out and I'm going to plug this here, and in the event begin play we are going to call the add tag from the BPC tag manager, and we are going to set the default tag standing. Okay, compile. Alright, so assuming in the initial start we have the standing tag here. Now let's say if I crouch or prone or any other tag that you have, in case you are adding more tags in this particular stance, we want to remove that because we want to switch to this new tag that has been occupied. So initially the stance tag will have the standing state. We want to remove that tag from the container and then update this value. So for this, bring out alt. And what will be that value? It is the tag that was added. So instead of naming it tag, we can change it to new tag and search for get new tag, because this is also the active tag. Okay, and this is what user wants. Now we are going to add a branch node here, and let's handle our first edge case. Now let's say you were running and you were in standing position. Now in between, while running, you change your stance to crouch. That means we should disable your running and we should make you walking. So that running tag should be removed and the walking tag should be added, right? So that's what this branch node is for. Let's search for matches tag. Now when you will be running, that running tag will be present in this locomotion tag variable. So we don't need to search the tag container. Okay, we already know what you're doing. So we will plug this into tag 1 and we will check, are you running? Because running is the only locomotion that is not allowed in the crouch position. So we will do exact match. If it is true, that means you are running. So we will first call the exclusive remove, and then we are going to call the exclusive add to add the walking locomotion. So why we did this is because at the time of running you change the state. That means you are receiving the input. That's why you are able to run, and since you are able to run, we have to switch it to walking. Okay, so that's it for the stance tag. That's the only edge case that can happen at this moment. And now instead of going to the movement, I want to go to the locomotion first. Now, like we discussed in the presentation, locomotion is allowed in every situation. So first thing that we are going to do is remove whatever locomotion you were doing earlier. So for that, we are going to bring this locomotion tag here and we are going to search for exclusive remove. And now we set the new locomotion that you are doing. Plug in the new tag, that is the get new tag, and we are going to plug this here. Let's discuss the edge case that can happen here. You are in a crouch state, you started running, then we have to make you standing if you are not. So let's bring out to match node here, matches tag, duplicate it. So first thing we will check is this new locomotion that you are doing, is it running? Because this is the edge case here, and we want to check if your stance is standing or not, because running can only happen in standing state. That's the idea in our game. It is not necessary. Okay, so I will check the standing only. So if you are not standing and you are running, that means we have to correct your stance. So for this, we are going to go for a branch node. This branch node is going to take this condition. And now there are two things that you need to do. First, exclusive remove. Whatever stance you were in, let's say you are in a prone position. Now you immediately started running. So in that case, I have to remove that tag. So I will bring the stance tag. I'll plug this here. And I will bring exclusive add, and I will add the standing tag because you want to run and you are not in the standing position. And then this new standing position has to be placed in your stance tag as well once everything is done. Okay, why we didn't do it before? Because if we did this before, then you cannot access this stance tag which you were having. Okay, I hope this makes sense. I have beautified the branching. The logic is still the same. So now let's code the movement cases. Let's bring the branch node first. Now what we want to check is the tag that you just occupied or adapted, is that moving? Okay, so I'm going to bring the matches tag. I'm going to check for moving. So if you are now able to move, okay, you pressed W, right? Or let's say you are falling from sky and you hit the ground and someone changed the tag to moving, then only you will get this moving tag, and we are just confirming that. So if you got that moving tag, whatever locomotion tag you were having, we will enable it. So if you are holding shift while falling, you cannot run. And even if you are pressing W, you cannot move or run. But as soon as you hit the ground or you press W, then we want to allow your locomotion. So for that, we are going to plug in the locomotion. But here is a catch. Now, if you are not having a previous state, that means this locomotion tag is none. All right. You are not pressing anything. So that means you do not want to run, you do not want to sneak. That means you just want to walk. So we are going to make a function, call it get valid tag, and this is going to take two inputs, tag 1, tag 2, and then we are going to search for gameplay tag and this one as well. So now why I created this is because if the locomotion tag is none, then we want to set you to walking. But if it is something, let's say running, then we want the running tag. So instead of coding the logic here, we can create a reusable function for this. We will bring out a return node first. This return node is going to give us the valid tag. So let's say result tag. And we will also ask, is tag 1 valid? Okay, so this function is just going to check if the tag 1 is valid or not. If it is, then return it. If it is not, then return the tag 2. Now even if the tag 2 is invalid, we don't care because tag 1 is already invalid. That's why you reached on the tag 2, and we change it to boolean. And now we are going to bring out is gameplay tag valid. And now let's connect the tag 1. So for that, get tag 1, connect this to this and this one to this one. Now to choose between these two based on the boolean response, we are going to select the select node, pass this tag 1 to this, tag 2 to this to keep the line straight. Okay, now we are going to use the not. So if the tag 1 is not valid, then return the tag 2. Doesn't matter if it is valid or not. But if tag 1 is valid, then return the tag 1. And if the tag 1 is valid, then this goes to the boolean. Okay, we are set. Let's also add a comment here. So let's group this, make a comment. So if the tag 1 is valid, return tag 1, else tag 2. Save and compile. Go to update tags. Bring out the get valid tag here. Now the choice was between locomotion tag that you are having earlier. We don't know if it exists or not, but if it exists, then we want this. Otherwise, tag 2 that we want by default is the walking. Okay, so the default movement is walking for us. We are going to bring another branch node. Now in this, we are going to check if the tag 1 is valid, which is nothing but this locomotion variable. That means it is also present in the container. So we have to remove the locomotion tag, no matter what it was, from the container, so that we can add the new tag. So we will search for exclusive remove. Now no matter what result tag is, this branch will only follow if it is true. So if it is true, that means it has to be a locomotion tag. So okay, and once the old tag is removed, we are going to add the new tag based on this result. So let's plug it. And also if there is no alt tag, then also we want to add this new tag. Okay, I have beautified the things a bit. Now let's go on the further logic. Now once that new tag is added, we also want to update our locomotion tag, because now this is what user wants and this is what we are going to follow. So we are going to connect this to this. Once this is done, we also want to have the movement tag. Let's first change the categories of locomotion and this into active tags so that we have things bit organized. Now we want to set the movement tag as well, because this was for managing the movement and the movement was simply moving. Why I said moving is because here in the branch node we check if that new tag was moving. Now if it is true, then we are going to add this moving tag only. Okay, so one last case that is also repeating, which you can copy from here. Now let's say when you're receiving the input for movement, that means this movement flow will run. Now let's say at that time you are in the crutch state and you are holding shift. That means you want to run from crutch state. So we have to again make you stand up and running. Okay, so for that we are going to copy this logic that we did here. Instead of copying the whole thing, we can create a function, but I'm unable to come up with a better name, so you guys can suggest in description if you have something in your mind. But for now I will just extend it and I will copy this part and paste it here, and I'm going to connect this branch node with this execution pin. Now this tag one is nothing but this, so we are going to check if your locomotion tag is running and you are not standing, then we are going to make you stand up, and we are going to update the stance as well and also update the container. So this is done. Now you can save and compile. Alright, so we are done with the side effects of adding the tags. Now let's focus on the removal. Now to handle the removal, we have to go in the remove tag. Again we are going to check whether the container has a tag. So if there is no tag, then there is no point of calling the removal process. Also let's remove this. Since we are already having exclusive remove here, just bring it. This can do our job. But before we call it, we want to have a branch node, and this branch node will call this if the container, that is the gameplay tags, contains the tag that we are trying to remove. So get tag and put this here and connect this to this. Now if the container has the tag, then only we are going to remove it. Otherwise we are going to proceed for the tag removal. But now we do not know the tag category. As of now we do not have any validation layer, because the only thing we need to check if you have a tag or not. So that can be done with this node. So let's bring the determine tag macros that we have created, and let's plug this tag one here. Now like we made this function, this is going to tell us based on the parent tag whether which category has been changed. Let's create a function, call it update tags after removal. Okay, now we are going to take two things. First is the tag itself that was removed, and the second would be the tag category that we are going to receive from the macros. Change this to e underscore single tag categories. Okay, now let's go back to our remove tag and bring this here, duplicate it, okay, and we forgot to connect this one as well. We save and compile. Now let's go to our last function, that is to go for after removal. Alright, let's focus on the edge cases now. Since we are receiving the tag category, we are going to bring out the switch node, single tag categories. Okay, so if it is locomotion that was removed, so as of now you just have a control on shift that is used for running. So if you have any other tags, you can define your own logic. If you press W or release the W, that is counted as a movement, not as a locomotion. Although when you are pressing W or ASD, the default motion is counted as walking, but the control locomotion is running only at this moment. So we are just going to bring the set locomotion tag. Now if you are releasing your shift key, doesn't mean you are not walking. So releasing the shift key has two cases. If you are running and then you just release your shift key, that means you are walking. But if you are not walking and you are just holding shift just to run and you release that, then we should set this locomotion tag to none. Okay, so we are going to use the select node for this. Now what we are going to check, if you are moving. Okay, so for this we are going to bring the match tag. Let's put it above and connect this to this. Now if your movement is on, then in that case we want to enable walking tag. Otherwise, we will set it to none, and we can call the exclusive add, and this will add your tag. Now remember, in the exclusive add, why we did this check is just for this, because if this results into none, then we do not want to add the none tag. So that's why I asked you to add that check over there. Now this is done. That's it for the locomotion, man. So for the movement, we are again going to require branch node. Now here we will check again whether you're moving or not. For this, let's copy this match node, bring it here. Now if you are removing the movement tag, that means you are releasing your hand from WASD. So you are not allowing your character to move anymore. So if it is true, then we will remove it. But remove what? We are going to remove whatever locomotion you are doing. So for this, we are going to use state.locomotion and remove any match. So we do not know what kind of locomotion you are in. There could be multiple, so that's why we created this remove any match. I highly recommend to use it when you are totally unsure what could be the tag present. So instead of writing 100 lines of logic to check and find, prefer to use this one. Now once that locomotion tag is removed, then we want to set the movement tag to none, because you do not want to move, right? And we are going to bring a branch node again. Now that is going to check if you are running or not. So the locomotion tag will come here. We are going to go for matches tag, and we are going to connect this one to this one, and we are going to check if you are running or not. Exact match. And if you are not running, that means you are either walking, which is the only case at this moment. So we will set the locomotion tag to none, because walking, we do not store that. Okay, so that's it for the removal of movement. Let's go to stance. Remember, this function will be called only when you remove a certain tag. So we are dealing with the side effects. Don't get confused. So I'm going to do this stance part now. Let's bring the stance here, and let's bring this tag here. Connect this to this. You can only reach this part if you are in some other state other than the standing, because see, the only way to remove the standing tag is by adding some other stance tag. So if you are standing and you press control, we go crutch. So in the game, our idea is if you press the control once, then you will go crutch. If you press it again, then you will uncrutch. So it is your responsibility in Blueprint that you call the correct tag to add and remove for the stance part. Okay, so that means if you press the control once, you are going in a crutch state. As soon as you go in the crutch state, the add tag will be called and it will automatically remove the standing stance, right? So that means from standing, if you go to some other stance, it will be dealt with the add tag function. And now if you are not in a standing state, that means you are in crutch or prone, then we are going to handle that. So you can come in this part only when you are not in standing. So first let's call the matches tag, compare it with the standing instead of comparing with the all, and let's select the select node, plug this to this, make in some space, connect this one to this one. So if you are in standing state, which is not possible, so we will set it to none. Otherwise we are going to set you standing. Okay, that's the idea. Just run that test case in your mind with these two nodes, you will get it. So we are going to add that tag, right? So let's call exclusive add, and now we are going to pass this value to this. Now if the stance tag is standing, we are going to add it. If it is none, it will not add it. That's why I asked you to add that check in the exclusive add if the gameplay tag is valid. So that's how we save our mistakes. Okay, now once this is done, we want to check something. So for that we are going to need a matches tag node again, and I'm gonna check the locomotion. So let's say you are running and you've gone into the crutch state, right, by holding shift, and now you uncrutch. So under the crutch you can either walk or sneak, which we haven't implemented, but let's assume you can do at least two locomotion, walking and sneaking. So assuming that test case, we want to remove that tag, because we are going back to uncrutch state and we are also running. So first we check whether you are running, and if you are running, then whatever locomotion you were doing earlier, we will remove that. So exclusive remove, and the tag would be state.locomotion. Now we do not know right now, so we just go with the remove any match. And then we are going to go again in the branch node. And since you are still holding the shift key, that's why you are in this true branch, we are going to make you running. Okay, so you were running, you gone into crutch state, still holding the shift, and then you press control again to uncrutch. We remove the walking, but now we want you to make running. But the only condition to make you running is that you are still holding the W key or ASD key. So that is detected by this movement tag. So we are going to check again by matches tag that you are moving. So if you are not moving, then there is no point to make you running, even if you are holding the shift. So let's plug this into the branch node, an exclusive add, and you will be running. Okay, that's it. So let's save and compile. I congratulate you guys, you have made this far. Now it's time to test all our efforts that we made. So we go in our character blueprint. Oh, this looks a big fine mess. Okay, it doesn't look that nice, but it is good. What we are going to do is we are going to set another timer event. And this will print our variables that we were having in the tag manager. So in the widget, if we go to graph, we only have the tag section. We also want to print the variables that we have. So let's create an event for that. I will add a custom event, print active states, and this is going to call set text. So let's duplicate, connect this to this, and again duplicate this. And now we are going to use the user vars. This is the place for the right side. Okay, and we are going to take the input. So let's call it vars, and we select the string and name it user wants. I'm going to connect this to this. Save, compile. So let's create another variable, print user states. This is temporary just to show you the debugging process, but for now let's do this and create the custom event log user states. Okay, like we did before, we are going to set it to empty first. So set it to empty, bring this tag manager locomotion tag, and now bring another one that is stance tag and another one that is movement tag. Okay, now I know it is not looking good, but the episode is already reaching to its max limit in terms of time, so I'll be quick here. Let's make an array and let's add some pins so that we can have, so the first would be the locomotion, then the stance, then the movement, and then we are going to run a for each loop. So once we set the value empty, we are going to run a loop on the array, and the array consists of these three elements from the BPC tag manager. And again, we are going to call our get tag suffix function that we created here, and this is going to take the array element input. And now let's call the append string. Once we have this, let's add another pin here. First we want the user states, whatever that is there in this, and the B would be the new tag that is coming, and then we will add shift plus enter by a line break and some spaces, and this will give us a string. We want to set it to the print user states. So this is what we are going to pass to the widget. So for that, let's right click, disable this context sensitive, search for print active states. This is from the widget, connect to this, connect the output, and this to this. The debug interface, let's bring it here, connect it to this. Now we are good. But when it comes to run, we are going to simplify this now. Since we have done so much to handle the cases, we do not want to uncrutch if the running tag is not added. So if the running animation is not possible, then we do not want to uncrutch. In the add tag, we will add an output that says is added, and the boolean will be this, because there is a possibility that the tag is not allowed to be added. So in that case, we want to know, the source wants to know. So in that case, we are going to return and we are going to say it is added, but here we are returning early because of the false condition. So we'll say it is not added. Save and compile, go back, and let's remove this because we are going to handle that in manager. Okay, see how beautiful it is. And now if you add the running tag, then we want to check. And what do we want to check is that is crutched, and we want to bring the and boolean node. And now why we did it, because if the character is in crutch state and he is now running, then only you are going to uncrutch. So the uncrutch function is from the character movement component that we need to call so that we can make the capsule collider height up to the standing height. So we have to handle that same situation in the movement as well, because let's say you are in a crutch state, completely idle, no movement, but you are holding the shift. Now you cannot run because there is no movement. But as soon as the movement is added, we need to check if you are running, then we have to make you uncrutch. So let's call get ia underscore run. This will give you the value. We are going to add a branch node, connect this. If this is true, then we are going to uncrutch. All right. So this will take care of our characters mesh and the capsule that is containing it. Before we debug, there are two things that you should do. In the set timer by event, we should take it like 0.2. It should match with our timer here so that they are in sync. And we want to enable looping. All right. And also if any one of your tags here is none, then this function might throw an error. So here we can check first whether the gameplay tag is valid or not. So if it is valid, then only we are going to do all this operation. Okay. Otherwise, we are going to just return an empty string. Okay, I have beautified things a bit. Also, let's connect this tag here as well. So we forgot to handle the false branch here. So if the movement changes, that means if the new tag is moving, then we go with this. But if it is not moving, then we have to disable or remove the movement tag and the locomotion tag from the container. So for that, just simply call exclusive remove. This would remove the moving tag and just duplicate it. We will also remove the locomotion tag. So for that, we bring it here. And since you are falling, we will also set the movement tag to none because you are not moving anymore. So compile it. Okay, and then go to ABP base. This is our blueprint. This is what we did. In the event graph, we are having a listener that is bind with the locomotion change event. We go into our function that is going to update the is running state, and we are going to correct this. So now first we will check whether the running, so first we will check whether the tag that we have received, is it running or not. So if it is running, then we will use this is added pin. So if this is a running tag, then if it is added, then we will run. If it is not added, then we will not run. And if it's some other tag, that means in the locomotion there is another tag that has been added. So the running tag must have been removed. So we will plug this into this. Okay, because remember, locomotion can have only one active tag. So based on that assumption, we are doing this. And now before we debug, I think there is one more thing that I wanted to introduce so that it works correctly, is that you see when you are removing and adding, there is lot of notifications happening. That means every time I add or remove in this post processing function, everything is getting notified. So the idea is we are getting here only after getting our tag added. And since our tag is added and the other people are already notified, we should be only informing them when the tag has been added, not when it is removed. Because if you got a notification upon adding, that means something has been removed, because all the work we have done is for single category tags, right? So anytime if a tag has been added, that means something was removed. So we don't have to communicate that remove. Instead, we can just communicate, okay, this tag was added. That's it. So what we are going to do in the exclusive remove, we will add another parameter and call it notify. So by default, notify would be false and it should only be true by the remove tag. So this will save some calls for us. So we are going to remove this and we are going to have a branch node. Connect this to this to this, and we will check get notify. If notify is true, then only we will send the notification tag change. Okay, because this function is called by both the manager and the user as well, because user is calling the remove tag and remove tag is calling this. So the notification should only be sent in this case, where we go in the remove tag and we mark notify. That's it. Only the exclusive add will be notified. Now in our widget, let's add shift enter and some space so that everything starts after this, and also add some spacing in the blueprint logger. Just compile. And we also need to connect this false line to this, because if the tag is not present in the container, still we want to process the removal part because we are carrying states over here. So in the remove tag, make sure this false line is corrected. I'll mark it in the video when we are creating this function, but just wanted to notify here. Now compile. Now you are standing. If I walk, you see your tags are matching. Now if I run, it's matching. If I press Ctrl to crouch, you can see I'm crouch, walking, moving, but what I want is crouch, moving and running. I'm still holding my shift key. Now if I release it, you can see it turns out to walking. Now the running tag is not present in the active tags. So you see the line that we just connected works out here, because it's not necessary the tag has to be present over there. This is my input key. This is what I want. So I need to make sure that I process the tag removal even if it is not present in the container. Now if I start running again, you can see it changes to running, standing and moving. If I crouch and if I release my movement, that is W key, you can see it is crouching, only crouching, but what I want is crouching and running because I'm still holding my shift key. If I release it, it is only crouching. Now let's say if I press W, it says walking, moving and crouching. If I release again. Now if I press W, I want to walk. As soon as I press shift, it starts running. Yeah. And if I release W, then you can see it is just standing, but I'm still holding my shift key to run. If I release it, it's there. So the tags are absolutely working as per the game behavior, and what you want is still in the lobby, which will be activated as soon as the conditions or criteria are met. So I hope you like this video. This was a very long episode. I tried to make it as short as possible, but I was unable to do it. And do let me know your thoughts. So this particular tag manager was more inclined towards the single category system. It's not like that it cannot have both. It can have, but right now we do not have the resources and use case implemented in the animations and all to demonstrate that part. So in the future, in the incoming episodes, we will implement all those stuff in the game, and then we will come back to this tag manager and we will add the new requirements. I really appreciate if you have made this far to make this tag manager, and I hope you understood how the user keys play so much roles, and I hope you now understand how much it takes to control the game with the gameplay tags. It's not that easy. You have to keep track of all the use cases and edge cases that can happen when the user is playing. So that's it for the gameplay tags. I want to continue the remaining locomotion part. Once that is done, we will add more stuff to our game that will allow us to add multiple category system tags, and then we will come back to this tag manager. Till then, stay tuned, hit the notification bell and subscribe the channel, and I'll see you in the next episode. Bye.